Okay, this is the second video for the Core 2 classwork on February 8th, although your papers may say February 7th. Um, we are factoring trinomials that give us perfect squares. And I notice this one's going to give me a perfect square because I have 5 times 2 and I have 5 squared. So I'm thinking of this as 2 times negative 5n and negative 5 squared. And you notice I put parentheses around the negative 5 because if I don't, then I say square the 5, make it negative. I'm going to square negative 5, which means I'm going to take negative 5 times negative 5. So when I factor this, I end up with n and n. And I'm going to use my area model again to show me why that's true. I have n squared and I have 25. So I need n times n. And I need to multiply to get 25. I need to add to get negative 10. And I know that negative 5 will give me negative 5n, negative 5n. When I add those two together, I get negative 10n. Negative 5 times negative 5 gives me 25, which is what I need. So I know I can call this n minus 5 times n minus 5. I'm going to say that's equal to 36. And my second step, n minus 5 squared. If I have something times itself, I can say that it's squared. So instead of n minus 5 times n minus 5, I just say n minus 5 squared. That makes it nice because now I can take the square root. I know that n minus 5 has to equal 6. Square root of 36 is 6. Square root of n minus 5 squared is n minus 5. But I have to remember, negative 6 would work too. If I square negative 6, I put parentheses in my calculator, negative 6, close the parentheses, and then I square it. The calculator will multiply negative 6 times negative 6. I get a positive 36. So n minus 5, oops, I'm going to write more. N minus 5 could equal negative 6. Adding 5 to both sides, n equals 11, or n equals negative 1. That is my final answer. When I have a perfect square binomial, it makes it easy to find that number. It makes it easy to square root both sides and solve. 25 seconds. I would like for you to find a similar problem on the B list. Okay, so I had a number, n squared minus a negative number plus a positive number. I'm going over here, and on the B list I did all x squareds, and number 6 here I have minus 14 plus 49. Okay. Number 5 I have minus 12 plus 7. You'll notice though, 49 is a perfect square number, 25 is a perfect square number. So 6 is really closer to number 5. I'm going to connect number 5 to number 6, and I will give you 2 minutes to work number 6. get back to the A list. And I just did problem number 5. And I'm going to do problem number 6. And I want you to look at the similarities, first of all, between 5 and 6. I have a number squared plus 2 times the number times n. I'm sorry, minus 2 times the number times n. And here I have z squared minus 2 times the number times z. Here I was equal to 36, which is a perfect square number. I had 25, which is a perfect square number. I don't have that here on number 6. But on number 6, I think I can make that happen. We're talking about using algebraic methods to solve problems. I'm going to do some algebra here. Something Miss Bodie taught us, the addition rule of equality. I can add the same thing to both sides. And I noticed up here, 10n was 2 times 5, 2 times negative 5, and 25 was negative 5 squared. So I'm first of all going to call this z squared plus 2 times negative 4 equals 20. I'm sorry, negative 2 times negative 4z. If I want to make a perfect square, I have to add negative 4 squared. I'm going to do that. Negative 4 squared. I didn't leave myself a lot of room. I'm going to add negative 4 squared on the, I apologize. Negative 4 square that. I need to square negative 4, multiply negative 4 times negative 4. I don't want to square the 4 and then make it negative. Your calculator will do that if you don't put the parentheses in, and it's not what we're looking at here. So I take negative 4 times negative 4, I get positive 16. I'm going to add 16 to this side. I'm adding 16 to this side. But now I factor this. When I factor it, I can see this is z minus 4 times z minus 4. And I'm not going to draw the area model this time. I think some of you are probably getting tired of that, but you can double check it. Z times z gives you z squared. Z times negative 4 plus negative 4 times z gives me negative 8z. And then negative 4 times negative 4 gives me 16. So I would have the 16 here. I would have the negative 8z here. So I have a binomial times itself. I can say z minus 4 squared equals 36. So back to the problem I had before. By adding 16 to both sides of the equation, I made a perfect square binomial. That allows me to take the square root of both sides. So I can say that z minus 4 equals 6. Or z minus 4 equals negative 6. Because if I take negative 6 times negative 6, I still get positive 36. The calculator only gives me the 6, but negative 6 works just as well. And now I solve for z. And here I have z equals 10. Just like Ms. Bodie taught us, we add 4 to both sides. Z equals negative 2. And I write or, because I want to make it clear that either one will work. Good. Give you 25 seconds to find a similar problem. You're looking for z squared minus a number times z, and then nothing beside it, where you can add to make a perfect square binomial. 25 seconds. Okay, I'm looking for c squared, or in this case x squared, because everything on the b list is x squared. And here I have x squared, here I have x squared, but here I have x squared minus 6x, and no constant term. There's no number without a variable. So I'm going to connect number 6 to number 8. I would like for you guys to work on number 8. I will give you 2 minutes to do that. Number 8 from the B list, of course. Okay. So, we just did number 6, where we added something both sides to make a perfect square binomial. Now I'm going to do number 7. Number 7 is a little bit different. I have something there, so it's not like number 6, but I can make it like number 6. Number 6 I could make into a perfect square binomial. I'm going to subtract 5 from both sides. Once again, I'm using the addition property of equality. I can add a negative 5 to both sides, just like we did with Ms. Bodie. And now I see I have q squared plus 12q. I can make that into a perfect square binomial by changing this to q squared plus 2 times 6q plus 6 squared equals 45 plus, I added 6 squared here. I'm going to add 6 squared here also. Now I can factor the left-hand side. That is q plus 6 times q plus 6 equals 81. Once again, I'm going to call that q plus 6 squared equals 81, so that I can take the square root of both sides. Give myself a little bit more room so that I can say q plus 6 equals the square root of 81, or 9. But I have to remember, even though the calculator tells me 9, negative 9 works just as well. Negative 9 squared means negative 9 times negative 9. Negative 9 times a positive is a positive 81. Q plus 6 could also equal negative 9. All right, or there to indicate that either one will make the equation true. I subtract 6 from both sides, again using the addition property of equality. Q equals 3. Or Q equals negative 15. All right, or in my answer. Okay. So I didn't have a perfect square binomial. I didn't even have q squared plus 12q by itself so that I could make a perfect square binomial. But I got q squared plus 12 squared by itself. Then I could add what I needed to make a perfect square binomial, and I could take the square root of both sides. I'm building something where I can take the square root. Find the matching problem. And I'll give you 25 seconds to do that. You'll probably get done before that. You can start working on the problem. All right, q squared plus 12q plus 5. I'm looking for x squared plus something. And we used this where we had the perfect squares. Here I don't have the perfect squares. I have that same thing up here, but here I have a minus. So I'm going to compare these two. I'm going to connect those two. Because this is all plus, this is all plus. Okay? So essentially you have the same idea in number 7. In the B list number 7 that I had in the A list number 7. So go ahead and work number 7 on the B list. I'll give you 2 minutes. done number 7. Come back over here and going to number 8. And number 8, kind of similar to number 7, except in number 7 I had positive and positive. Now I have negative and negative. But we found before we could work with negative. Let's see if we can do that here. First of all, in order to do this, I need to build a perfect square binomial. And the first thing I have to do here is get rid of the 13. If I take half of negative 4 and square that, I don't get 13. So I'm going to use the addition property of multiplication. I'm sorry, the addition property of equality. Gets that out of the way. Now I'm going to think about this as r squared plus 2 times negative 2r. And I will need to add negative 2 squared. I add negative 2 squared to the left side. I add negative 2 squared to the right side. Negative 2 times negative 2 is positive 4. So I have r minus 2 times r minus 2. I'll just call it r minus 2 squared equals 49. I take the square root of both sides. Calculator says 7, but I also know negative 7 will work too. R minus 2 could equal negative 7. When I square negative 7 times negative 7 still gives me a positive 49. And to solve it, I add 2 to both sides. Or I have 2 options. Either r equals 9 or r equals negative 5. Either one will make this a true statement. And now, there's only one left to connect to. Only one that we haven't done. And that is number 7. Get number 6. Number 5. The only one that we have left to do. Number 5 is actually similar to number 8. So take 2 minutes. Do number 5. with the worksheet. If you would do the exit ticket, I would appreciate it. There are 3 problems on the exit ticket. They're similar to the problems we've just worked. Let me know how you do. Thank you.